Hey, good day, everyone. So today we're going to start talking about section 7.2, which we're going to get into double angles and half angle formulas. So for this section, we're going to kind of get away a little bit from the proving identities because we're going to get into that in 7.3. So in this one, there's some very important identities that we do have to cover. And really what we're going to focus on is the application behind these identities. So remember when I mentioned in 7.1 where you utilize identities and formulas to figure out values for things that we don't really have quick answers for. Like, for example, when you had to find the cosine of a certain value, but you really couldn't do it without a calculator. But if you rewrote it, you used an identity, you could actually transform it back into a reference angle that we used back in like the special triangles, 30, 60, 90, or something on the unit circle. That's actually where these identities are, they come in handy because they help us utilize those unit circle values, special triangle values, things like that to solve certain trigonometric functions. So in this video, we're only going to cover the half angle identities. The next video, we're going to cover the double angle identities. So for at least for this one, we're going to go over what all the half angle and double angle identities are. But for this one, we're only going to do the example problems for half angle identities. So up here on the screen, I have the double and the half angle identities. So the double angle identities are, sine of 2 times your angle is equal to 2 times sine of your angle times the cosine of your angle. That comes in handy by using the triangles, the unit circle, things along those lines. And, when you use those tools, it makes solving these problems a whole lot easier. The next one, cosine of 2 times your angle. Well, we got 3 different value or formulas we can use. It does not matter which one you choose. The first one is cosine squared of your angle minus sine squared of your angle. The second one, 1 minus 2 times sine squared of your angle. The next one, okay, the last one, 2 times cosine squared of your angle minus 1. Like I said, you can use either one of those formulas. They'll still get you the same answer. The last double angle identity is tangent of, tangent of 2 times your theta, or 2 times your angle. And that's equal to 2 times tangent of your angle, all divided by 1 minus tangent squared of your angle. Okay, so those are the double angle identities. You definitely want to be familiar with those. I would suggest getting a note card, kind of writing them down. Because the easy part is memorizing them. The hard part is working through problems and understanding how each little piece works. Now, the next set of formulas that we have are the half angle identities. Now, these guys, they look complicated, but they're actually not too bad because they're actually all very related to one another. So the half angle for sine, the first one that we have listed, is plus or minus the square root of 1 minus cosine of your angle divided by 2. Excuse me. The half angle formula for cosine is plus or minus the square root of 1 plus cosine of your angle divided by 2. So those two formulas are pretty much the exact same. The only difference is that the sine one has a subtraction sign, nudge, nudge, wink, wink, and the cosine has a positive sign. Okay. The reason why I said nudge, nudge, wink, wink is because sine starts with S and subtraction starts with S. So if you know that sine and subtraction, you got the first formula memorized. Okay, you always got to remember those little tips and tricks. The last half angle identity is the tangent formula. Now, your half angle for tangent is sine of your angle divided by 1 plus cosine of your angle. And that's also equal to 1 minus cosine of your angle divided by sine of your angle. So it's a lot of sines and cosines floating around. Now, that's, like I said, that's where those special triangles come in, the unit circle, things along those lines. All of that stuff comes into play, and those are tools that you definitely want to be familiar with. Also, too, something I do need to mention, the plus and the minus on the outside of the square roots, That all is determined by the angle, your a over 2, what quadrant that angle is going to be in. Okay, so let's start looking at a problem. Okay. So find the half angle value for the following function. Sine, excuse me, sine of pi over 12. Okay, so what that means, okay, sine of pi over 12, because it's half angle, that's got to be sine pi over 12 divided by 2. Okay, so because half angle, our angle A, as it relates to the formulas that we were just dealing with, your A is pi over 12, and you have a 2 at the bottom. Okay, so that's where we got this step here. All right, now to simplify a complex fraction, fraction divided by a number, remember, keep, change, flip, that would be equivalent to the sine of pi over 6. Wait a second, that angle sounds familiar. Haha, it's a 30, 60, 90 triangle. Okay, so if you are wondering where we get the values coming up on the whenever we're doing this problem, use your special triangles for pi over 6. Okay, so now I'm going to kind of bring my problem up to here, and that way you can follow along. So sine pi over 12 is equal to the plus and minus the square root of 1 minus cosine of our angle, okay, that we just found, which was pi over 6, all over 2. All right. So now we can start doing the arithmetic. So the square root of 1 minus, now the cosine of pi over 6 should be the square root of 3 over 2. And then you still have the divided by 2 on the bottom. Excuse me. All right. Now on the top, inside that radical, we've got 1 minus a fraction. Because we have, we're adding and subtracting with fractions, we got to find the least common denominator. So that would be 2 over 2 on the top minus square root of 3 over 2 on top, all over 2. Okay, LCD was 2. So now, when we simplify the numbers on the top, we would have 2 minus the square root of 3 over 2, still all divided by 2. Okay, that 2 doesn't go away. So yeah, we have a lot of 2's floating around. A whole lot of 2's. So to simplify this fraction, that 2 on the bottom here will get multiplied by this 2 on the bottom on the top here. Remember, keep your first fraction the same, change your division sign to multiplication, and then flip your second fraction. Keep, change, flip. So this would be 2 minus the square root of 3 all over 4. Okay. Now, we still have a fraction. We got it under a square root. But this square root can actually be reduced if you wanted to. Okay. So if you were doing this problem in my math lab or something like that, they would want you to reduce as much as possible. So this is actually how you would reduce. Because you have a square root of a fraction, when you take square roots of fractions, you take the square root of the top divided by the square root of the bottom. So this would be the square root of 2 minus the square root of 3 over the square root of 4. Now the square root of 4 is 2. So on the top, you would still have 2 minus the square root of 3. On the bottom, you would have 2. Okay? That would actually be your final answer. Now, something I do need to mention. At the very beginning, I started off with a plus and a minus. but I didn't keep it going. Maybe I should have. The reason why I didn't keep it going, okay, is simply because this pi over 12, okay, what we started off with, pi over 12 is located in the first quadrant. All angles in the first quadrant are positive. So that's why in my mind, I did not take those plus and the minus signs with me, because it is going to be positive. Okay. So right here, this would be your exact answer. Okay. There we go. Okay, this would be your exact answer. As a decimal, if you were to put this in a calculator, because sometimes my math lab or the program that you're using would want you to put it as a decimal, it would be equivalent to 0.2588. Okay. Excuse me. So that would be the exact answer, and then that would be the decimal answer. Okay. So just to recap, we took the angle that we were given, pi over 2. We took the angle that we were given, pi over 12. We divided it by 2. So that's where we got the pi over 6 from. Okay. So we used that pi over 6 in our half angle formula. So we didn't do anything else on the left side. On the right side is where we dealt with the pi over 6. Cosine of pi over 6 is the square root of 3 over 2. Then we had to get a least common denominator by adding and subtracting the fractions, combine the fractions, and then we get down to here. Okay. Then we took the square root of the top and the bottom. This is what this step is right here. See here? Yeah. And then we simplified our square root. So the square root of 2 minus the square root of 3 on the top, all divided by 2. Okay, and that's where we got our final exact answer from. Okay. But we also got our decimal number, which is 0.2588.